Hi, I'm gonna explain how to solve the problem 2 of first partial exam of Physics 2. The problem says like this. A large storage tank opened at the top and filled with water develops a small hole in its side at a point 16 meters below the water level. If the rate of flow from the lake is 2.5 per 10 elevated at minus 3 meters cubed over minute, determine first the speed at which the volume leaves the hole and then the diameter of the hole. So first we have to determine the speed. And here we have to analyze that the velocity, the pressure 1 and the pressure 2 are the same because they have the pressure of the air. So we'll have that pressure 1 it's equal to pressure 2, that it's equal to 1 atmosphere. Okay? Then we have to use Bernoulli's equation that says like this. The pressure 1 plus half density velocity 1 cubed plus the density times the gravity times y1 will be equal to the pressure 2 plus half density of velocity 2 squared plus the density times the gravity times the J2. So here we can see that the pressures are the same ones, so we can cancel them. We also can see that at the beginning, at the top of the tank, the velocity that the water descends, it's minimum. So it's more or less like zero. So we can cancel this. We are left with these three parts of the equation. And as we write them again, we have the density times the gravity times the y1 will be equal to half the density times the volume 2 squared plus the density times the gravity times the G2. Once we have this we are asked for the speed in which the water leaves the tank. So we have to get out of the equation the velocity, and we'll have that the velocity 2 squared will be equal to 2 times the gravity, because we have gravity here and gravity here, we can factorize it and put it outside. And this will be equal also to 2gh. Okay, and the h we know that it's 16 meters. Once we're left with these values, we can obtain that the velocity 2 will be equal to the square root of 2g times h. Once we have this, we obtain that 2 per the gravity per 16 will be equal to 17.7 meters over second. So as we can see, this will be the velocity 2. Now, for obtaining the diameter of the hole in which the water comes out, first we have to analyze again the rate of flow. The rate of flow, first of all, we have that it's meter cubed over minute. So we have to pass it to seconds, and we know that in 1 minute there are 60 seconds. So we have to divide the rate of flow into 60. And we obtain that rate of flow divided by 60 will be equal to 4.167 per 10 minus 5 meters cubed over second. Once we have this, we can use the rate of flow equation, because we know that the rate of flow it's equal to the area times the velocity. And we know that the velocity in the outer part is this one. So we will have that this, that is the rate of flow, will be equal to the velocity, that is this one, 17.7, times the area. If we get the area out of the equation, we obtain that the area will be, well, the area 2, because this is the velocity 2 and this is the area 2. Okay, the area 2 will be 2.354 per 10 minus 6 meters square. And we are asked to obtain the diameter. So we know that the area it's equal to P r squared. And once we have that P is equal, that the area is equal to this, we can obtain the diameter from here. So we'll have that the radio will be equal to the square root of 2.354 times 10 over P, if we get the radio. And these will be equal to 8.7656 per 10 minus 4 meters. But the radio, it's half of the diameter. So if we want to obtain the diameter, we have to, that this it's equal to the diameter over 2. So if we multiply this result by 2, we obtain that the diameter will be equal to 0.0017 meters, that it's equal to 1.7 millimeters. And this is how you solve problem 2 of partial 1 of physics 2.